I go along. So for instance, if I do CD bang dollar, does anybody know what that does?
No.
Okay, so this is bash. Bash has a whole lot of very interesting variables that let you access history and kind of different state that exists in bash as you go along. The state that this bang dollar accesses is the bang means the previous command and dollar means the last argument of the previous command. So what I'm effectively typing is CD, this is the last argument. So CD code platoon. And that comes in handy a lot more often than you might think. And partly because it's very short. So here we are. So now we can do the git clone. Okay, and that's just literally what I've got there in the handout. Any syntax errors or anything. So you should be seeing something like that. And then if that's the case, you can go right in there, and you probably know about hitting tab to autocomplete. If you're on a Mac, your environment's probably set up for that. It just looks at what directories exist and tries to match them if it can, basically. Okay, so here we are. This is the repo we'll be working with. We'll be doing a tiny bit of committing to it as we go, excuse me, and but mostly just looking to see how it's constructed, especially at first here. So one thing that we will do is to get the database in a form that we can look at easily, because Git does a little behind the scenes housekeeping that we don't really need, and that is to pack it up before it sends it to us. So for instance, if we look into the Git database, which is everything that is the repo is under .git. So we can see that there's only a couple things here under the objects, which we would normally expect there to be a lot more. And the reason is because I'm going to up arrow and then type that pack. Everything is down under this big thing down here, this .pack file. So we're going to use a little script that pulls that out for us. And that's what this unpack objects does. So you can go ahead and just type /unpack objects.sh. And now if we look into that .get objects directory, we should see some more things. And if you take the -L off, kind of get a better idea of what it is. Okay, so and if we look at the pack directory, it's taken that packed file away because it's no longer needed. Everything's been exploded into this format that we see here. So we don't have to worry about packing and unpacking normally. So this is just for the purposes of seeing what we need to see about how Git is put together. All good so far? Any questions? Okay. So more setup. So your bash shell has a couple of files that it reads when it starts up every time, and those files have various configurations in them, I guess you could call them. One of those configurations is aliases, and these are shortcuts you can define for when you're typing commands. So for instance, git commit, you know, it's not that many letters, but it's still more than something like GC if you could just make it be that. So git aliases has a few of those. So the format is, alias is the statement, and then your alias name equals, and then whatever you want your alias to map to. So these are all the aliases that I use a lot for Git. GD for Git diff, GC for Git commit, and so on and so forth. We'll use this top one a lot as well. This lets us see the Git graph as we go and commit and branch and merge and all that kind of stuff. So there's a few .sh, which is, those are just convention for representing an executable shell script. And so we're going to run this one. And we can do that by just, actually, before I do that, let's look at it a little more closely. So this ls-l is for long, ls long format, this file. And over here, you see a bunch of odd-looking notations. This is basically groups of three groups of three that define what the permissions are for this file. And each of those three groups represents I guess a set of users. So if you go from left to right, now dash means basically not set, R means read, W means write. So there's a set for user, and then the next set is a set, I'm sorry, I'm a little off. The first dash is something else. So RW dash is for user, the first R dash dash is for group, and the second R dash dash is for other. So what this says is that user has read write, group has read, and other has read as well for this file. So based on that, probably this thing won't work if I do this. Sure enough, because I forgot to set this other bit over here. So this threesome applies to me because I'm the user running the file. But that last bit is executable. The one that's not set here should be after RW. So I have to set it. And easy way to say it is to say U for user, add executable, like that. So chmod is short for change mode, the permission mode that is. Now if I look at it, now it's executable for me only. It's still only readable, not writable for everybody else. So now because I've done that, now I can type / git and tab to autocomplete, and it actually runs as a script. So these are all actually executable commands in a bash shell. So now these aliases should be in place. So for instance, I can type alias GC to see what GC is, if anything. If it's not anything, then it just tells me that, but this one's actually set. So I can type, there's a GS, which I use a lot for status, get status. So if I type GS, it tells me what's going on. Now notice that it actually knows that I've changed the permissions even though the content hasn't changed. So if I wanted to save that, I would need to go ahead and add and commit, get aliases, which I'll do someday, but I don't think I will worry about it right now. Where are we now? We've done this. Okay, so here we are, get aliases. So that's accomplished, adding those aliases to our current shell, but it doesn't set us up for the future. So if I go down in this other shell below, cd the same place and type, you know, gs. Actually, that's crazy. It does that. Well, no, that's because I've already done all this for my home environment. For you, it shouldn't work until you do this next part here. And the reason is that each shell it has its own environment. And so, you know, I've run this and made these aliases active in this shell, but unless I've got it somewhere else, and specifically in those files I described earlier that the shell runs every time it starts up, it's not going to be there. So this append command does that for you. So we can cat it if we like here. Cat is a Linux command for basically show the contents of. Concatenate is its mnemonic. So it's some bash script. Bash is a fully fledged scripting language, fully fledged you know, programming language. It's not easy to read, but you can write pretty much almost anything you want in it. So what we wrote here was basically grep is something that goes and finds a string in a file. So it says if, and bang means not. So if this string is not found in this file, then go ahead and run this code here. And what the code does is find out what shell you're running. So we're running bash, and if you run base name of that shell, sort of mimicking what the script is going to do, it just takes the end component of that path, which is the base name, and then it sets our profile variable to that something that corresponds to that base name, which in this case, because we have bash here, it's going to be something like .bash profile. Tilde is the shortcut for our home directory. So we're basically spitting out this whole content of this thing we just ran, this get aliases.sh, and appending it, these double arrows or double right brackets mean append to this tilde/.bash profile. And then we echo what we've done. So let's see if it works. So for me, nothing would have happened because it would have seen that I basically have already run it and already have this alias defined. But for you guys, you should be able to run that and then see, assuming that you have bash as your shell, you would do something like cat space tilde/dot bash profile. And see, at the end, you should see, you know, these aliases like this. So I've got a few extra in there, but I do have the alias adog defined, so you didn't modify my bash profile, but it should have modified yours. So is that working for everybody? I'll give you a moment to sort of check and see that took place. One way you can make sure that it took place is just try the GS, for instance, and see if it operates. If it's not there, it'll say something like that. Command not found. Also, because you're in a shell or you're in your repo context, you're in your repo right here, you can type adog and see, you should be able to see a graph of the commits in this repo.
So I'm in my bash shell right now, but I'm running it on a Windows.
Okay.
Will that negatively impact this or no?
So where's your bash shell coming from? What install? Is it Cygwin or?
I can't even tell you right now.
Okay, it should still, I mean, bash is bash. You might have to use backslashes instead of forward slashes. But actually
Okay.
forward slashes should still work in even Windows bash.
Yeah, they do.
Okay. And it should still honor a bash profile in your home directory. So that, all that should work. Are you seeing your mileage vary?
It's just the command didn't take. That's all. Just
What
recent.
did it
I might
say?
have typed something in wrong. I'll just go through the steps again.
Okay, yeah, let me know what it says and I'll be able to offer some insight. It should be pretty much the same. The main difference in Windows is that you'll see things like you know, /c/ you know, users, or you know, like that, instead of just home users login like you see, or home login like you see in, well, on Mac you'll see users, but on Linux you'll see /home, something like that for your, but the behavior should be very similar. So yeah, let me know if you run into anything that indicates that that's not, and we can, well, I'm sure we can sort it out in one of the breaks. Okay, so ideally, you've got to this point. We're ready to sort of begin looking around in this Git repo. Did everybody get a chance to look at the basic Linux and shell stuff? Let's see if I get this somewhere else. Where did that go? Basic Linux and shell. So these are the commands we'll be using. Should I go over those commands briefly? Does everybody have a grasp of what those are?
If you wouldn't mind quickly going over them.
They should know some of them. Some of them we haven't seen before.
Okay. Which ones are the top ones you haven't seen?
I don't know. PWD, make directory, of course. CD, of course. Vim, I suppose activates Vim. I don't know what PS is or what grep is. Or
Okay. Right. So PS, I'll start from PS. Then that's process status. So if you want to know what's running on your box, I don't know if Windows will do this, but this is what you would find for Linux or Mac. You can find out a little more by giving it some more arguments. It's short for process status. So you know, you can, there's a lot of stuff running on your box. You can use various arguments to filter out the output to kind of what you want to see, but if you want to know, like, you know, what's taking up CPU or what's running, or if something is running, then you can use PS. Maybe you want to know just like if a certain thing is running, like Google. So that's when something like grep would come in handy. So if you could say PS, and then you sort of use pipe to filter the output, or to pipe the output to another command. That command could be grep. I would type something like this. And what that says is grep is short for get, regular expression, and print. So the regular expression is this in this case, the word Google. It's just a literal string, but I could say like something like this. Oops, where am I at? Let me start over. So if I did something like that, that would find Google, but it would also find a bunch of other strings. Basically, it says anything that has the letters OG with 0 or more before and 0 or more characters after it. So that's an example of a regular expression. I don't really need it in this case. I'm just know I need Google. The -I means ignore case. So if it finds Google in uppercase, it'll still return value for it. So now I can see that I've got a bunch of Google processes running. So I won't go over the various fields of them right now, but that's basically, you know, PS. And then grep is handy for, you know, filtering streams. It's also handy for just any given file. Like I used it briefly to find ADOG, you know, in my .bash profile. So by itself, it just prints the line that has the string that it found, right? I can also have it print just the file name. So it says, okay, here are the files that have it, that have ADOG. I could just also look in all the files. Didn't like a directory because it's a directory, so that doesn't make sense to grab a directory for a string. Although you can use -R, and that basically looks through all the files in the whole directory tree that you're in, all the way down for files that have that string. So when I do that, then it says, oh, okay, I know what you want to do now. If you want to look at all the whole tree of directories, so here's what I found, right? Those files. Of course, if you want to see the contents instead of the file names, you can just take off the -L. So simple in concept, but there's a lot to it, and it's incredibly handy. When you're looking for code to refactor, for instance, and you want to find instances of a variable, and you just want to go through your whole code base and make sure that you know you've got it all, you can just grep -R for recursive, I for ignore case, and L for, you know, just show the files, and, you know, have something like, you know, whatever the old variable name was. And dot means start at the current directory, and boom, it just goes and it looks through your whole directory tree and makes sure that you've got it, all the examples of that thing you're trying to refactor taken care of. So that's grep. PWD is print working directory. LS, I like these 4 options here a lot. -A shows stuff that's not normally visible with just LS. With basically a dot file specifically. They're in the directory. The -R reverses the order. So if you use -T for time, it shows she's probably -LT would show you better. So this isn't very useful because they're all the same time, but let's try maybe my home directory. See if I can something more useful. There's tilde. Okay, so you can kind of see, okay, March. Yeah, March, and then it goes kind of earlier. So this is 2019 back here, right? So often you want to see the latest, so you can use R for reverse, and then the latest ones show up last, latest files. So that can be handy for diagnostic purposes. Okay, PWD CD cat is concatenate. Just basically list out the contents onto the output stream. Maker Vim. I won't go into Vim right now. I'll try to try to minimize my use of Vim because other platoons have found it confusing mixed with all these other concepts we're pulling out here. So that's basic Linux commands. I think that should cover most of what we're doing. That's Linux-like. We'll add some stuff that's Git-like, but using these Linux commands. So Linux shell concepts. We've talked about bash profile a little bit. Bash RC is another of those files. The bash profile gets run when you open a new login shell, and the bash RC gets, and it typically runs the bash RC as well. If you're just running a shell just to, you know, echo, just to say something, you know, run another command, then only the bash RC gets run because you're just using the shell to just, you know, get done whatever you're telling it to do, and then it's exiting again. So sometimes there's some relatively heavy-duty things that go on in the bash profile that you don't really need just to invoke some subcommand. So the shell is usually set up to just run a very sort of minimal set of configuration, which may be none. You may not even have a bash RC, but that's why those both exist in this world. Let's see what we should cover next. I talked about types a little bit. You saw the IO redirection that I could use with PS and pipe to grep like that. Comes in handy for building filters. There's a lot more to that. You might see me use greater thans and less thans here and there. I'll try to call those out as I do that and explain what they're doing. Linux has this notion of 3 standard streams, I guess you could call them. So the standard input is basically where things come from if you don't specify it. And the shell, when you open up the shell, it has these standard input, output, and error attached to specific things. So in the case of the shell process, which is just another process, you know, we could do a PS and grep bash and see our own process. It's one of these. We could look at the it's the PID, or actually no, it's a special shell variable for you right here. $$ is your process ID. So this one is this one. That implies that this one here must be the one down below. But anyway, the shell has standard input, which is the keyboard. So when I enter things from my keyboard, it appears, you know, on the, it's received by the shell. The standard output is this terminal. So it's set up to, when I do type something from the keyboard, it not only does it go into the shell process, but the shell echoes it out onto the terminal so I can see what's going on when I'm typing, which is incredibly handy. So the other standard pipe is the standard error, and you see that in cases where you grep for something that's not there, you know, in a file that's not there perhaps. So it appears on the terminal, and the reason it does, this is an error message, and the reason that appears is because standard error is also directed out to the terminal, but I could make it go somewhere else. The way I would do that is to use, if this is more shell stuff, I'll stop in a minute. I know this is a lot, but the shell references those 3 handles by input is 0, output is 1, and error is 2. So if I want to take error and make it go somewhere else, you know, maybe an error file, I can do that. So it basically says take standard error and redirect it into this other place, which in this case is a file. And if I look what's in the file, that's that message that was spit out on the standard error string. So I will stop there because I'll only get more confusing if I go. But as you see, as you work with the bash shell, you'll see this used extensively. This notion of pipes, redirection, standard input, output, and error. Cover one more thing here, the environment variables, and then stop and take about a 10-minute break. So there's a bunch of environment variables. You can see what they are by just typing E and V. I'm actually going to type Command K on my Mac to clear the screen so that you can know what actually corresponds to the E and V output. And you see these, key equal value. There's a bunch of different variables that are set up in our environment. There's some that are standard. You almost always find a user and or log name, depending on the system that you're using. You'll almost always find a home variable set. This is useful because Bash has a shortcut that if you go CD dash, it goes to the previous directory, which you can find by keeping track of it in this variable. If you do CD dash again, it goes back where you were. So I can see that now. That's the old PWD. So the most important variable here is path. Well, I mean, most important one to learn about, I should say. So path is how Bash finds what it should execute. So you see this value here that path has. Let me just echo it out. That's probably going to be easier. It's a colon separated, so it's several paths actually, and it's a search specifier. So if I type something like Ruby-V, okay, it somehow finds where Ruby is and runs it. Well, how does it do that? You use which to say which Ruby it's being executed. And so it's the one that's here. And that's implies that it must have found it in this path. And the order makes a difference. So there's also Ruby in user bin. Well, I'm 100% sure. Okay, sure enough, there is. Notice it's a different version, but it's not getting run because user bin is further down the path than this path here. So that's important when you kind of get off in the weeds in different times and are running something you think should be running. That's probably has to do with the way your path is set up and what's installed where. So yeah, anything executable is going to be have to be on your path in order for it to run, and that's why we look at like what we ran before, this get aliases. Notice I didn't just type get aliases because that won't work. Well, why won't it work? Because where I'm at is not on the path. Right? There's no user C walk with source code Platoon learning get on this path. So even though I'm right there, it doesn't, it's just right there. It doesn't honor it as something to run because it's not on the path. So a couple of things I could do, I could change the path, to say dot, or my full users, whatever. I wanted to type that much, or I could just say dot, and then a colon, and then the rest of the path. Not that. So now I screwed up my path. So let's try that again. Because I put actually to set my path to something that didn't exist here. So now I've screwed up my path. So now basically nothing that I type will run. Yeah, so even ls is not found until I fix my path. So let's set path to what I meant to set it to. Dot colon and then no dot colon and then this stuff. Okay, ooh, ls works again. Okay, so now I can say, I should be able to say, and now, you know, it runs without complaining because now dot is in my path. That said, this is a bad idea because dot can change, so you may not end up knowing what you're running. So you should basically never do that. And that's why I went ahead and, so let me change it back. So now the better way to do it is just to you know, give the full path on the command line, and then it will run like you expect, which is why we did it that way initially. Because now we're telling it exactly where it is. Dot being in shorthand for your current directory. One last comment, this export. Bash has environment variables. It also has shell variables. So the difference is that if I were to run another shell, which sometimes you do, you know, I said that bash dash c echo hi. I mean, you can run commands in your shell script that have different commands in them. Show an example with this append. You know, this guy runs another subshell. These backticks is shorthand, or it's syntax for spawn up a subshell and, you know, execute this code in that subshell and give me the result. So if I do that, then I care about whether these variables exist in that subshell or not. So export basically means go ahead and make those things appear in all the subshells that run. If I just said, you know, path equal without the export, that would work for this shell, but it would not be, that value would only be here in this shell, not in subshell. So we can say something like Fred equals hi, and then we can say bash should go into a subshell, and Fred's not there. We go Control D to get out of that subshell. Check on Fred. Now Fred's there. We do an export though. Bash, now go to the subshell. Now John is there. So just an example of difference. Okay, any questions real quick, and then we can take about a 10-minute break.
So export is like an environment variable within that shell, and then the consequent subsequent shells inherit that kind of.
Yeah, export basically means you know, set it here, but then make it available. Like you think of it, it's kind of shining down into any subshells that run. Export means project that variable down into all subsequent subshells. So, you know, that's kind of it's a nesting effect almost. Whereas if you just say variable equals value, it only holds for your current shell. Okay. All right, let's take about a 10-minute break and reconvene at about 5 after.